Nová Škoda Elrock. Nabitá touhou objevovat. Nová Škoda Elrock. Nabitá touhou objevovat. Nová Škoda Elrock. Nabitá touhou objevovat.
Hello, I'm Mike, and I can't believe how easy it was to create an iOS app in minutes using this one AI tool I'm about to show you. And what's more, I've got no previous experience making iOS apps, and I didn't even know how to code, but the AI tool did it for me. Before we dive into that, I was delving into my YouTube channel analytics and noticed most of you who watch my videos are not subscribed to the channel. Would you do me a huge favor, please, and hit the subscribe button? It really motivates me and helps the channel to grow so I can do more videos just like the one you're about to watch. So without further ado, let's dive in. What are you going to need? You will need a Mac of some description. I'm using a Mac Studio, a MacBook, iMac, anything like that will do perfectly. You're going to need to download Xcode from the Apple App Store. It's an Apple app and it helps you to write the code. Well, you won't be writing the code. The AI tool will be doing that for you. But you'll need that to create the app, okay? And then you're also going to need to download a tool called Cursor AI. It's incredible. I've used it for a lot of coding projects, and you'll see a video on your screen now and in the link down below if you want to dive deeper as to what Cursor can do. First, what you're going to need to do is load up Xcode and create a new project. Now, make sure it's very important that you select iOS up on the top menu, and then choose App, and then go Next. Now, you need to give the app a name, so I'm just going to call it Tide Times because I'm going to make a Tide Times app. And then you'll need to select a team. Now, if you haven't got this set up, don't worry, I'll show you how to get your name in there as the team. Organization identifier can be your domain name backwards. So if you had the domain example.com, you'd do com.example. I've got the domain mrc.fm, so I'm putting fm.mrc. Not easy for me to say. fm.mrc.tidetimes is the full identifier. You don't need to worry about that or any of these other options. Just click Next. And then it's going to say, where do you want to save the files for the app? I'm going to choose my desktop because it's easy. I'll click create and you'll see, up there, it's created a Tide Times folder and it's also created all the initial files for my app. And these are just testing files at the moment. We're going to write the code with the AI tool I'm about to show you. Now, I did say, how do you get your name appearing if it's not there already? Well, you need to go into the Xcode settings up here, and then you'll see you've got a bunch of options. You need to go to accounts and make sure you've linked your Apple ID. Take a look at the screen here and you'll see Hello World. Yes, that's right. It's given you some sample code that displays Hello World on the iPhone screen, which is pretty cool. And I can actually change world to Mum, like that. Hello Mum. Okay, and it's really cool. I can also change globe here to smiley, like so. And look, now I've got a smiley face. So that's basics of manipulating code. And once you've seen enough, even if it's AI generated code, you can kind of read it with your human eyes and say, I know what that's doing. So this shows you how easy it is to get started. But we're not going to write any code. We're going to use Cursor to do that. Let's take a look. This is Cursor. I'm going to actually go ahead and make it full screen and make everything a bit bigger. Now, there's just one option when you load Cursor for the first time, open a folder. And of course, if I go to my desktop, you'll find the Tide Times folder right there. It's very easy. Click open, and you have essentially linked Cursor now to your iOS app project. It can now start writing code for you. So you'll see here, if I pop these open, these are like folders, and these are the code files. And actually, if I open that one, you'll see Smiley, Hello Mum. Yeah, it's all there. Everything that I did in Xcode is now linked into Cursor. Let's start making that app. And to do that, we're going to use Cursor Composer, which is going to write all the code for us. Watch this. Hit Command, Shift, and I on your keyboard, and you'll see you've got an untitled composer. This is something fresh and new that you can use to start writing your code. So what am I going to do? Well, first and foremost, I want to make sure to follow Apple best practices when creating my app. Now, you can train in Apple best practices to Cursor so your app turns out to be perfect. How do you do that? Type the @ in Cursor Composer and start typing docs, and you'll see docs appears like that. Now, you'll see I've already trained in some previous documentations, but I can add a new document here. Now, this is where I can add a web page. And you'll see, actually, if I go and bring this Chrome screen over, I have got a bunch of different websites open. First of all, I have got the Swift documentation. So I'm going to copy the URL to Apple Swift like that and paste it in here. And we'll give it a name, Apple Swift.
Yes. Hello everyone. This is March 1st. So today I'm gonna start covering the
I can recommend a resource. I'm going to put a link in the description.
It's
so
Letters x1, x2, those do not have x1 squared. It doesn't say the square root of x1. It doesn't say arc cotangent of x1. It just says x1. So what characterizes a linear combination is that this is basically x1 to the 1 power, x2 to the 1 power, x3 to the 1 power, etc. Okay, so that's a linear combination of those variables, and the letters, the AI, are called. And then we always want to solve these things. So we always want to find some real numbers that work in the equation. So if you have some real numbers that work in the equation, you must have n of them. That's called a solution of, or you say that this n tuple satisfies the equation if you substitute these numbers in for the x's and you get the right answer. And what we will mostly be interested in is when you have many of these. One sometimes, but more often 2, 3, 4, 5, lots of them. That'll be a system of linear equations, and we'll say that something solves a system if it solves every equation in that system. So this is kind of a quintessential mathematical activity. We'll be given a collection of equations, and we're looking to make define the real numbers, in this case down here, x, y, and z, that make all the equations true. And this is very typical kind of linear system. It's got 3 linear equations, and we're looking for x and y and z that make all 3 of those equations true at the same time. Now, naturally, we want to solve them by some systematic way, looking at it and saying, you know, well, it seems to me it's just not going to do it. We're going to learn a method that it always works. That is to say, it always gives you the solution to the problem. It has the advantage that it never gives you something that isn't a solution. And we'll call this triangular form, where they fall off to the right, we'll call that echelon. Down the right thing, he or she wrote down the right thing but made a mistake and didn't realize the z's cancel. Okay, so please, I urge you to has to hold here that this system has no solution. There can't be any x, y, z that make all 3 of those equations true at the equation where z leads. That's what marks infinitely many solutions. So let's look at another example that I hope drives that point home a little better. So don't say to yourself, look for 0 equals 0. No. Say to yourself, look for a row for every letter. All right, so here I have the x plus y plus z equals You go through some Gauss's method steps, and I didn't bother you with the actual arithmetic of those. A set of solutions to the linear system that you started with. All right, so we're describing the solution set, so I'll write down some linear system. Here is a 3-equation, 3 unknown linear system. Looks perfectly innocuous. You wouldn't know it to look at it, that it has some special character to it. It really isn't a special character. True linear systems can do this. You go through some Gauss's method steps, and I didn't bother you with the actual arithmetic of those steps because we covered that last time, and because in my experience, after a little bit of practicing, people don't have too much trouble with it at all. You end up with echelon form. And we see here the characteristic echelon form that implies infinitely many solution, namely that there is no equation in which one of the letters z leads. The 0 equals 0 takes the place of an equation where you might expect to see z leading, but there isn't an equation with z leading. Instead, there's this sort of placeholder 0 equals 0. Okay, so we want to describe, there's infinitely many solutions, we want to describe them all. We want to somehow write down the equation. equations that mark them all. And here's the technique, and I can't overemphasize how much we will be doing this technique throughout the course of the semester. It is looks like a small point when you first see it, but it is a key to understanding much of what we're going to do. So the idea is to take the letter that is in some sense missing. Z doesn't have a row, so we're going to take Z. You could do other things, but this will turn out to always be the thing we want to do. So you take the letter that is in some sense missing, the Z, and you express the letters that are leading in terms of those that are, the technical word is free. So I'm going to express Y in terms of Z, and then I'm going to express X in terms of Z. So expressing Y in terms of Z is very easy. You just move all the stuff over until you have Y equals, and there's some expression on the other side of the equation with Z's in it. And I always write them left and right. So I always put the Y equals on the left and the Z stuff on the right. Just a habit, but I don't see any reason to do it any other way.
I've been exposed to such a rich tapestry of cultures.
It's so cool. Like, we enjoyed it so much.
Okay, so what about expressing X in terms of Z? Don't we have a mixture of X and Y there? And the answer, of course, is that we're going to substitute into that first row. So in the place of Y, we're going to write minus 6 plus 4Z. So we get minus X, and there's the minus 6 plus 4Z, and there's the 3. So we get get minus x, and there's the minus 6 plus 4z, and there's the 3z, and you do the necessary algebra, and you bring everything over to the other side of the equation. It turns out that when all the smoke clears, you get x equals, and then there's a 3 minus z. So I now have z, of course, z is itself, but I now have the other letters, the y and the x, in terms of z, and that will be what we always want to do. We always want to express the leading variables in terms of the other variables. I'll call that parametrization. And we'll spend an awful lot of the time doing that. When you're doing homework, an awful lot of time, the answer will be parameterize. This description of z can be whatever you like. X and Y depend on Z. This description is awfully convenient because it enables you to take a Z, 1, a 2, a minus 1/2, 127, a 3,409.6. You take whatever Z you like and you generate an XYZ, an XYZ, an XYZ, an XYZ, however many XYZs you like. It's obvious that there are infinitely many XYZs because they have to be different. It can't be the case that they're all the same because they all differ at least in the Z place. So there are infinitely many solutions here, and I will say parameterized by Z. This enables you to find solutions to the system, to the starting system, but it also enables you to conclude something isn't a solution to the starting system. Because if somebody says to you, what about 1, 6, 3? You say to yourself, 3. So if I put in 3 for Z and I put in 3 for Z, I don't get a 1 and a 6, so that can't be a solution. So that's to say, when you have y and x expressed in terms of z, you have a criteria for solutionhood, whatever is the right word. You have a way to tell whether or not something is a solution, and that's exactly what we want. We'll call that parameterizing. This is one example. Of course, I'm going to do another example in just 30 seconds, but this contains all the information you need. There are some letters, only one letter in this picture, there are some letters missing from the echelon form system. There's some letters that do not lead a row. We use those letters to express the other letters. We parameterize the leading variables in terms of those that are not leading variables. And that parameterization serves as a criteria for what is a solution and what is not a solution.
Hi, my name is Mojo, and I'm a senior software engineer at Booking.com. I'm super excited to be speaking at Monster Scale 2025. I will be speaking
express the other letters. We parameterize the leading variables in terms of those that are not leading variables. And that parameterization serves as a criteria for what is a solution and what is not a solution. When you call something this, so I now have I can't open to after a sequence of steps and then get to a house system. It really says throughout the interim the equation, the prime option is one takes what these finds exactly all I'm not leaving but in fight. And then the variable free in the same sense in this way of thinking about it. And then the variable that we use to describe a family of solutions is called a parameter. The way that we will proceed is we will parameterize using the free variables. A person can say to themselves, well, I could have expressed z in terms of x. Yes, you could have. But when we're solving solving these systems, we will always parameterize, we will always express our solutions using the free variables, and that just turns out to be the convenient thing to do, so that's what we'll do. Experience from later on in the course shows that this is the way to go, so rather than start out the wrong way, go start out the right way, we're going to parameterize with the free variables. I don't want to hear any more argument. Solutions say to themselves, well, I could have expressed z in terms of x. Yes, you could have, but when we're solving these systems, we will always parameterize, we will always express our solutions using the free variables, and that just turns out to be the convenient thing to do, so that's what we'll do. Experience from later on in the course shows that this is the way to go, so rather than start out the wrong way, go start out the right way, we're going to parameterize with the free variables. I don't want to hear any more argument. Okay, here's another example. I already put it in echelon form because that's not the hard part. What differs between this and the previous example, of course, there's no 0 equals 0, but we discussed in the last video that the 0 equals 0 is really a canard. That's really not the point. What the point here is that there is no equation in which z leads, and for that matter, there's no equation in which w leads. So I have two leading variables, x and y, and just by taking them away, what's left is z and w are the free variables. So I'm going to parameterize this system. I will express the solutions to this system. I'm going to parameterize this system using the free variables, using z and w. I will express y in terms of z and w. I'll have an equation that says y equals, and on the other side of the equation will be some stuff involving z and w, and I'll also have an equation that says x equals, and on the other side of the equation will be some stuff involving z and w. I will parameterize the solution set using the free variables z and w. And again, I know it's not brain surgery, but And we're going to do it so much through the rest of the semester. I'm very keen that the words sink in. And it's not especially hard. I mean, obviously, everybody can do this. To express y in terms of z and w, move stuff over to the other side of the equation. You worry about the SIGN, and you end up with y equals minus 6 plus z plus 4. W. Up here, a person might say, well, what about the y? It's in the way of expressing x in terms of z and w. But we saw this in the previous slide. No, substitute for y what you just figured out. Y is minus 6 plus z plus 4w, and then you have a whole bunch of stuff, x's and z's and w's, and you move everything but the x over to the other side of the equation. You get rid of the 2, all this other, you end up with x equals 11/2 minus z minus 3/2 w. So I have expressed y in terms of the free variables. I have expressed x in terms of the free variables. So I have parameterized the solution set using the free variables. And again, that's, we can't see everything we're going to do at once, but this is, we will want to do this throughout the rest of the semester. Okay, another one. looks like the first one, some small change. Here, the free variables are not z and w. The free variables are what? Right, leading is x and z, and the remaining ones are y and w.
Ochutnejte křupavé, do zlatova opražené lískové oříšky zalité sametově jemnou čokoládou Lindt. Tak krémový, tak oříškový. Lindt Nuxor. Od švýcarských mistrů čokolády Lindt.
Nová Got to Be suchá šampónová mlha pro svěží vlasy. Vyzkoušej Got to Be suchou šampónovou mlhu.
So the only difference between what's up here and what's down here is which variables are going to be the free variables, which variables we're going to parameterize with. You don't necessarily parameterize with them sort of left to right. You can end up with sort of x and a z down here, and the y is stuck by its lonesome. But nonetheless, we will use y and w to express x and z. All right, so you start off, use y and w to express z. Z equals 1/4 plus 1/2 w happens not to involve any y's. If you like, you can think of it as involving 0 times y. In any event, I've expressed z using only, or at most, the letters y and w. And down here, then when you go up to x, you say, well, z is equal to 1/4 plus 1/2 w. W, you put that in place, you get an equation that has x's, y's, there's no longer a Z, there's now W's, and you move everything over, and when all the smoke clears, if you do the arithmetic right, and sometimes it takes a while, if you do the arithmetic right, you get X equals, and then there's some stuff over there. There may be some constant, and there's a coefficient for Y and a coefficient for W, and there you go, you're done. You've expressed X and Z in terms of Z and W. There we go. X is it's not very pretty, but something involving Y and W. Y is just, I don't know how else to write it, so I just wrote it as Y equals Y. It's can strike a person as a little silly, maybe it is, but I wanted to write down all 4 letters in terms of those two, so I just wrote what I had. There is Z expressed in terms of Y and W, and there's W expressed in
Echelon.
I'll show you like how the way I'm taking notes while studying, just to give you a clue what I'm doing.
It's a little silly. Okay. An example that goes start to finish. The Gauss's method part doesn't sort of keep us awake at night here. There we go. Minus 2 row 1 plus row 2 gets rid of, so that only the x in the first row is left standing. Minus 3/5 row 2 plus row 3 uses the minus 5 to get rid of it, and you end up with a y there. And then you have this system here. You noticed, of course, that that there are 4 letters, x, y, z, and w. 3 of them lead a row. 1 of them does not. So I'm going to express the x, the z, and the w in terms of the y. The only thing that happens, the zeta rows, x, y, z, you know there. There we go. Minus 2 row 1 plus row 2 gets rid of, so that only the x in the first row is left standing. Minus 3/5 row 2 plus row 3 uses the minus 5 to get rid of it, and you end up with a y there. And then you have this system here. You notice the 2 plus row 3 standing, so that only the x in the first row is left standing. Minus 3/5 row first row go. Minus 2 row 1 plus row 2 gets rid of, so that only the x in the first row is left standing. Minus 3/5 row 2 plus row 3 uses the minus 5 to get rid of it, and you end up with a Y there, and then you have this system here. You noticed, of course, that that there are 4 letters X, Y, Z, and W. 3 of them lead a row. 1 of them does not. So I'm going to express the X, the Z, and the W in terms of the Y. The only thing that happens here is that W is in fact determined. Did you notice down here 22/5 W equals 65/5 gives you right away W equals 3. Technically, that's W expressed in terms of Y times 0Y. So there we go. Times 0Y. So there we go.
Presne to, čo som potrebovala. Môj top dezert s našľahaným proteínom. Len od Erman.
First time on the show, Scale AI founder and CEO Alexander Wang. His company provides accurately labeled data to help companies train their AI tools. And back in 2022, he became the youngest self-made billionaire in the world. Pretty amazing.
Thanks for having me on.
I want to go straight to what we were just talking about off camera, which is the idea of where the U.S. is on AI versus China, because you have some very surprising statistics that I think will probably, frankly, freak out some of the viewers.
So, yeah, first of all, the AI race and the AI war between U.S. and China, I think, is one of the most important issues of today. We took out a full-page ad on the Washington Post on Tuesday saying that, America must win the AI war. And so this sort of relative race in AI between the U.S. and China is critical. Today, we released Humanity's Last Exam, which is a new evaluation or benchmark of AI models that we produced by getting, math, physics, biology, chemistry professors to provide the hardest questions they could possibly imagine that are relevant to their recent research to really put the test to the models. To give you a sense, no model is getting above 10% on this test. That being said, what we found is that DeepSeek, which is the leading Chinese AI lab, their model is actually the top performing or roughly on par with the best American models, which are O1 from
Okay, so
OpenAI.
I think we have been all under the impression that the U.S. was way ahead of China as it relates to AI, in large part because we have access to, NVIDIA GPUs and chips and other things that supposedly the Chinese do not have. I keep hearing from people all week, from Chinese AI executives that they say we're so close, and by the way, we're doing it with one hand tied behind our back. Our algos are better. We're actually going to figure out how to do this, do it better than the U.S. and in even a more energy efficient way because we don't need these super powerful chips. Are they happen to be right?
There's two things happening. First, it is true. It has been true for a long time that the United States has been ahead. And that's been true for, maybe the past decade. That being said, the very recent event on Christmas Day, about a month ago, DeepSeek released a model, which, by the way, I think is symbolic that the Chinese lab releases, an earth-shattering model on Christmas Day when, the rest of us are sort of celebrating the holiday. And they released it to much fanfare, and then they followed up with their reasoning model, DeepSeek R1, which is the one that we evaluated as top of the leaderboard. The reality is yes and no. So the Chinese labs they have more H100s than people think. And these
are the highest powered NVIDIA chips that they were not supposed to have.
Yes. My understanding is that DeepSeek has about 50,000 H100s, which they can't talk about, obviously, because it is against the export controls that the United States has put in place. And I think it is true that, I think they have more chips than other people expect, but also on a go-forward basis, they are going to be limited by the chip controls and the export controls that we have in place.
How do you, you work with everybody, so I don't know if it's fair or unfair, but how do you stack rank these large language models and who ultimately is going to be a winner? Or are they all so close and it gets commoditized?
The interesting thing that we see right now, so we actually specialize in this. We've produced our SEAL evaluations, our safety evaluations and alignment labs, evaluations which measure across many different dimensions. We measure across math capabilities, coding capabilities, multilingual capabilities, and reasoning capabilities, and many different dimensions, including tool use and agent capabilities. And what we see is different models are better at different things. So it's hard to put a clear stack ranking among all the models. For example, the OpenAI models are extremely good at reasoning, but the Anthropic models might be really good at code. And sort of there's a diversity of capabilities of the models. That being said, I think what we're seeing in general is the space is becoming more competitive, not less competitive.
I keep hearing from business leaders here that they're all playing around with, OpenAI, or they're playing around with Claude, which is the Anthropic model, or they're playing around with Gemini, et cetera. And then they're going and using Llama. They're going to find some open source version to try to get close to what they could approximate these other guys doing because of just the different price points of these things. Do you think that's the future of this? I think like in a Linux world.
There's definitely a dimension. It comes down to ultimately the level of capabilities and intelligence that are required for your use case. I think ultimately what we're going to see is, what we do with all the leading labs, including OpenAI and Google DeepMind and Meta and many others, is continuing to push the frontier and push the boundaries. And so how do we leverage data, given that, as an industry, we've sort of run out of publicly available data? How do we generate new data to keep pushing the frontiers? And our belief is that, advanced capabilities are going to enable incredible use cases where you're going to be willing to pay for those increased capabilities. But for the more simplistic use cases, those will probably go more towards open source or more basic models.
We've been talking all morning about Stargate and the debate happening on Twitter between Sam Altman and Elon Musk about whether they really have $100 billion or $500 billion. Satya Nadella was sitting in your chair just yesterday saying he's got $80 billion, his money's real. He took to Twitter. What do you make of all of this? You know all these players.
So much is on Twitter anyway, so I'm not sure I have
or X, we should say.
Or yes. X. But I think one thing that is very real, regardless of sort of Stargate specifically as a program, is that the United States is going to need a huge amount of computational capacity and a huge amount of infrastructure. So this was actually we wrote a letter to the Trump administration on recommendations on how to ensure that the U.S. stays ahead. And one of them was really around infrastructure. We need to unleash U.S. energy to enable this AI boom. And that's clearly what we're seeing right now, which is, in addition to the Stargate program, many of the major AI companies and major clouds are going to be looking to build giant data centers. So
the reason I asked this about the different companies doing this, do you ultimately think we need 5, 6, 7 companies all trying to build frontier models? Or, there's been a talk forever that, in a different, if Lena Khan hadn't been running the FTC, would have Amazon wanted to buy Anthropic already, for example? Or would have Microsoft bought OpenAI, or would have some of these folks, so there wouldn't be as many, everybody competing against each other in the same way? I don't know. Maybe you think the competition is great. I just don't know how long term, how many models there ultimately will be like that.
I mean, our view is actually that this is potentially going to be one of the greatest markets or the greatest industries ever. You know, right now, let's say there's between 10 and $20 billion of LLM-based revenue. And if you believe that we're actually on a track towards superintelligence or agent.
Nikdy nevíš, na koho narazíš. Jameson, ochutnáš, pochopíš. Nikdy nevíš, na koho narazíš. Jameson, ochutnáš, pochopíš.
My name is Alexander Wang, and I'm the founder and CEO of Scale AI.
Alexander Wang co-founded a company that supplies one crucial resource that tech giants need: humans. His company that supplies one crucial resource that tech giants need: humans. His company, Scale AI, supplies high-quality training data to NVIDIA, OpenAI, General Motors, Microsoft, and Meta. This data improves language models like ChatGPT and supports applications in the field. For instance, Scale AI's human workers combined with AI tools help GM self-driving unit crews by labeling data to differentiate a pedestrian from a palm tree or a puddle from a manhole cover. They also label behaviors, such as predicting whether a person is about to cross the street. All of this helps AI systems make better decisions on the road. Alexander co-founded Scale AI in 2016 at the age of 19, just when AI technology was beginning to take off. Before that, at 17, he was already coding for the question and answer site Quora, where CEO Adam D'Angelo advised him that while 4 years of college was overrated, 2 years might be valuable. Well, Alexander ended up dropping out of MIT after his freshman year, where he had been studying computer science and math, to start Scale AI with fellow Quora alumni Lucy Guo with an investment from the startup accelerator Y Combinator. Alexander initially told his parents it was just going to be a summer project, but deep down he knew it had the potential to be something far bigger. He and Lucy recognized that self-driving car companies had amassed millions of miles of driving footage to train their AI systems, yet lacked the human power to review and label the data, tasks that machines can't handle. Scale AI stepped in to meet that demand. It was like striking gold in the digital age. Even Alexander's first name has a touch of serendipity, spelled with 8 letters, considered lucky in Chinese culture because 8, ba, rhymes with prosperity or wealth, fa. One of the early believers in Alexander and Lucy's vision was Excel partner Dan Levine, who not only invested $4.5 million in seed funding, but also offered his basement as Scale's first office. Major investors later jumped on board, with Peter Thiel's venture capital firm Founders Fund investing $100 million in 2019. Lucy ended up parting ways with Scale AI, reportedly due to differing vision in 2019. Lucy venture capital firm Founders Fund investing $100 million in 2019. Lucy ended up parting ways with Scale AI, reportedly due to differing visions between her and Alexander, though the specific reasons have never been publicly disclosed. Today, Scale AI is valued at $14 billion, with Alexander owning an estimated 15% of the company, making $14 billion. With Alexander owning an estimated 15% of the company, making him one of the youngest self-made billionaires. Initially, the company relied on outsourcing agencies in Southeast Asia and Africa to hire workers for data labeling, but realized managing this in-house was more cost-effective. In 2017, Scale AI quietly launched Remote Tasks, which now employs over 240,000 workers across 90 countries, including Kenya, the Philippines, and Venezuela. They work out of internet cafes or leased offices. While Scale AI doesn't openly advertise its connection to remote tasks, the platform has faced accusations of operating digital sweatshops, where workers have reported being paid far below the local minimum wage, with some earning less than $1 a day for certain tasks. Despite these allegations, Scale AI has stated that they are proud to pay rates at a living wage. Some of its workers are now tasked with more complex responsibilities. Instead of simply labeling pre-existing data sourced from the internet, they help create new data to teach models how to generate images or complete text, like in ChatGPT. For example, if I showed an AI system photos of my dog Luffy, it might generate a sentence like, "This dog is adorable and sweet and happy." While factually accurate, it doesn't sound like something a human would naturally say. A human labeler might edit it to sound more conversational, like, "This sweet, adorable dog looks so happy and playful." But Scale AI hasn't just focused on everyday dog looks so human labeler might edit it to sound more. It doesn't sound like something a human would naturally say. A human labeler might edit it to sound more conversational, like human would naturally say, and happy. While factually accurate, it doesn't sound like something a human would naturally say. A human labeler might edit it to sound more conversational, like, "This sweet, adorable dog looks so happy and playful." But Scale AI hasn't just focused on everyday tech. The company has pivoted toward military contracts. Scale AI has been supporting U.S. military operations by analyzing satellite images to assess damage in Ukraine caused by Russian bombs. To ensure sensitive data is handled securely, the company employs U.S. workers for data labeling at its St. Louis office, though most of its workforce remains global. Alexander was inspired to take action after a 2019 trip to China, where he watched the country's top engineers give presentations on AI and was left feeling uneasy. He later told Forbes presentations on AI and was left feeling uneasy. He later told Forbes they were really dodgy on what the use cases were. You could tell it was for no good. China has accelerated its investment in AI technologies, for example, in autonomous drone swarms that operate like a swarm of bees to incapacitate the enemy.
If we don't win on AI, we risk ceding global influence, technological leadership, and democracy to strategic adversaries like China.
For him, the mission to protect America is deeply personal. He grew up near the Los Alamos National Laboratory in New Mexico, where both his parents worked as nuclear physicists. The lab is famous for developing the atomic bomb. His parents worked as nuclear near the Los Alamos National Laboratory in New Mexico, where both his parents worked as nuclear physicists. The lab is famous for developing the atomic bomb during World War II. Just as the atomic bomb defined the last era of warfare, he believes AI now represents the future of defense.
Military implementations of AI are going to be incredibly important. We need to ensure that in this next phase that the U.S. is both economically dominant, but also has military leadership as well when it comes to artificial intelligence.
Alexander advocates for centralizing military-ready AI datasets, such as satellite imagery, intelligence reports, and sensor data, critical information not readily available on the internet. Despite the U.S. Department of Defense generating 22 terabytes of data daily, far more than China's People's Liberation Army, a large portion remains underutilized, often stored on hard drives that end up forgotten or overwritten. He emphasizes the need to centralize this data into a single repository where it can be processed, labeled, and made AI-ready for military use.
Data truly is the ammunition that will power, our future efforts in the military.
Although Scale has established a strong lead in AI-powered data labeling, its approach of hiring and managing data labelers can be replicated. Other companies such as Surge AI, Labelbox, and Snorkel AI are already stepping into the same space. But Alexander is confident that Scale AI maintains a significant advantage. He told Forbes, "I would say that we've been working on this problem longer and have built more technology than anyone else." Scale's edge may come from Alexander himself. William Hockey, the billionaire co-founder of fintech company Plaid, who sits on Scale's board, said this to Forbes. "Wang didn't get to where he is because he's a boy genius. MIT pumps out a lot of teenage dropouts. He has an absolutely insane work ethic." But for Alexander, hard work isn't enough. His leadership emphasizes active thinking, a constant push to question assumptions and test ideas with data. As he explained in a memo to his team, ensure to ask questions, challenge assumptions, and identify where the real bottlenecks and constraints are. It is the only way you will be able to sort through the noise to identify the reasons you failed. Alexander warns against nice syndrome, where large groups avoid challenging important ideas for fear of seeming impolite. He advocates for a culture that promotes questioning assumptions on critical issues, ensuring that ideas are rigorously tested. None of Alexander's success would have been possible without mastering coding, and you can build those same skills with Brilliant. Brilliant's Python courses teach you to code from day one with their drag and drop editor. I like that it's completely hands-on, so you're learning by doing. Plus, Brilliant's new data science content lets you analyze real-world data to train you to see trends and help you make better decisions. Whether
Lindor. Darujte jedinečnou chvilku s novinkou Lindor malina se smetanou.
It's such a trigger for me. Like, she's so nice, but it makes me so uncomfortable. I mean, you did grow up in a chaotic.
So these are the new digs on Alex.
New office. It's been a great setup. We have responsibility to produce all the data, truly generate the data necessary to fuel this next era. What worked before is not going to keep working. Our responsibility is to utilize the exact same infrastructure and data foundry that we've built to support every enterprise in their own. Our responsibility is to utilize the exact same infrastructure and data foundry that we've built to support every enterprise in their own journey to make use of all of their proprietary data towards building customized, specialized agents for their own businesses.
You must still do a lot of college recruiting, right?
I mean, when I would say dropped out to start the company, so I have a strong conviction in talent right out of college. We have an office in New York, an office in DC. We just started an office in London.
Well, that's amazing. Thank you very much. You were sort of born in the AI era. So where do you think we are in the development of this? Are we getting to the stage where, musical chairs are done, we know who the main players are, this game is over? Or, are we in the first inning, the third inning? Are we, getting settled into it?
To me, the first inning was sort of the tinkering phase of modern deep learning.
Yeah.
So from ImageNet and AlexNet, so ImageNet was the first large-scale labeled image data set. AlexNet was the very first use of deep neural networks to solve that problem. There was like the Google result where they could recognize cats in YouTube videos. All of that was sort of, basically like call it 2009 through really probably 2020 was the first inning. And while it was quite a while, it was really a lot of tinkering with different kinds of model architectures, different kinds of data sets. It was the first demonstration that showed that scaling these models up really worked. A lot of the progress from GPT-2 through GPT-4 was all in pre-training, was all training on, more bigger and bigger chunks of the internet on more and more GPUs. And then basically all of the gains from that point, which was, March of last year through today, August of 2024, have been through gains in post-training.
Yeah.
And this is through better SFT, RLHF, DPO of the models, and the use of, data sets of increasing complexity, going into more and more expert areas, and really driving for the performance of the models using high, quality over quantity. So smaller data sets, but a very, very high quality.
Now you're actually creating effectively data sets that are unique to the explicit purpose that the model maker wants, right?
Exactly, yeah. So we think about our role now as more of a data foundry than a data annotator. The industry is very, very excited about agents.
Yeah.
There's very little data that can train these models of what are the series of actions that a human takes and what is their internal thought process as they go through each of those steps. We actually view one of our most important roles, especially over the next few years, is to lay the groundwork for agents to actually become a possibility in the industry.
I'm guessing that the biggest opportunity for agents is actually more in the enterprise space, and that enterprises are going to need very specific kinds of agents to do the work that they do. So what does that mean for Scale in terms of developing your business over onto the enterprise side?
Our responsibility is to utilize the exact same infrastructure and data foundry that we've built to support these large AGI efforts, to support every enterprise in their own journey to make use of all of their proprietary data towards building, customized, specialized agents for their own businesses.
Yeah.
The freezing wind cuts through Gaza's camps, leaving families desperate for warmth. But with your help, we can change that. Gaza's camps are filled with people
So where we see a lot of enterprises struggle today is in the jump from pilot to production. Is your pilot model good enough to actually ship to production? And then if it isn't good enough, if it's good enough, great, deploy it and continue monitoring. And if it isn't good enough, aiding in the process of tuning the model or improving the model with proprietary data or with new data to get to that point of production.
I know one of the topics that you are pretty passionate and talk about is AI safety. There's obviously the ongoing debate between, sort of
Scale AI is a company that provides AI-driven data labeling and annotation services, primarily to help train machine learning models. They specialize in high-quality labeled datasets for applications such as autonomous vehicles, natural language processing, NLP, and computer vision. Key aspects of Scale AI. Data labeling and annotation. Scale AI helps companies annotate images, videos, text, and sensor data, making them usable for AI models. Industry served. Autonomous vehicles, providing annotated images and lidar data for self-driving cars. NLP and generative AI, training chatbots and large language models, LLMs. Defense and government, assisting the military and government with AI-powered solutions. Healthcare and retail, offering AI solutions for diagnostics and automation. Technology and automation, they use a mix of human labelers and AI-assisted tools to improve annotation accuracy and efficiency. Funding and growth. Scale AI has received significant investment and is valued at several $1 billion, making it one of the leading AI infrastructure companies. Do you want to explore how Scale AI fits into your AI business plans? It could be useful for data annotation in your AI automation agency. Rocket.
History of Scale AI. Scale AI was founded in 2016 by Alexander Wang and Lucy Guo. The company
Scale AI was founded in 2016 by Alexander Wang and Lucy Guo. The company was created to address the growing need for high-quality labeled data to train artificial intelligence models. Key milestones in Scale AI's journey. 2016, Scale AI was founded by Alexander Wang, CEO, and Lucy Guo. 2017, the company secured its first major funding and began working with AI-focused companies, particularly in self-driving technology. 2018-2019, Scale AI gained traction as a leading provider of data annotation, expanding services to industries such as government, defense, and enterprise AI. 2020, the company became a key player in AI training for autonomous vehicle companies like Tesla, Waymo, and Toyota. 2021, Scale AI raised $325 million in a Series E funding round, reaching a valuation of $7 billion. 2022 present, the company continued to grow, expanding services into generative AI, large language models, LLMs, and defense AI applications. Founder and leadership. Alexander Wang, a former MIT student who dropped out to start Scale AI at just 19 years old. Lucy Guo, co-founder, who later left Scale AI to start her own ventures. Current status. Scale AI is now one of the most valuable AI infrastructure companies, playing a crucial role in enabling AI-driven automation and machine learning applications across industries. Would you like to explore how Scale AI's services could be useful for your AI automation agency?
Go, W.
Unleashing through open source. Where do you think that all lands? And maybe talk talk also about this in the context of sovereign nations and how that plays out and the importance of this in terms of, the democratic nations being able to keep our universe more or less the way it is?
I think over the next few years, it will become more and more obvious that these models are powerful and that we need to be thoughtful about what their capabilities are. And I think even today, we already see some of that with disinformation campaigns powered by AI. If you look through the history of tense geopolitical situations or wars writ large, technology plays an incredibly key role. And there's no technology more important today than AI in terms of its ability to fundamentally shape how this all plays out.
There was always this never-ending conflict between the good guys and the bad guys. Each would reassess and understand the new context under which they were competing with each other, use the latest and greatest tools, and then attempt to outcompete with each other. How realistic is it to think that the bad guys will be prevented from access versus a reality of we just have to be constantly, the good guys have to be just constantly ahead in terms of innovation, technological development, et cetera, et cetera?
I think you're right. Some of that may change now. The export controls of high-end chips to China is quite draconian and could start causing more divergence. But to your point, I think it's unrealistic to believe that we could ever have a huge gap in capability between the good guys and the bad guys. But it's also our responsibility as a nation, I think the United States as a nation, to figure out how we ensure that lead is as great as possible.
Yeah. No, that makes a ton of sense. We just got to stay ahead.
Yeah. And then I think it's, one of the AI safety is such a strange topic, but my true belief is that if the United States maintains leadership in AI, you avoid a lot of the most devastating scenarios of AI safety.
Would you say that there's a sufficient amount of awareness and preparedness for what's about to happen? And is there the level of investments that necessary for us, for the good guys, to stay ahead?
The total investment from tech giants into AI programs will exceed the entire U.S. defense budget at some point, in the next however many years. So that I think is a bullish sign for America. Where we're not seeing the investment is actually from the U.S. government itself, and
preparedness for what's about to happen, and is there the level of investments that necessary for us, for the good guys, to stay ahead?
The total investment from tech giants into AI programs will exceed the entire U.S. defense budget at some point, in the next however many years. So that I think is a bullish sign for America.
Guys, to stay ahead.
The total investment from tech giants into AI programs will exceed the entire U.S. defense budget at some point, in the next however many years. So that I think is a bullish sign for America. Where we're not seeing the investment is actually from the U.S. government itself, and so I think it's a very real scenario where in the commercial sector we have exquisite AI capabilities, but none of that tech translates to military or national security advantages that enable us to prevent all these really bad outcomes. Just as a simple example, the United States on data and AI, the United States Department of Defense on data and AI invests, depending on how you count it, 3 to 10 times times less than the Chinese People Liberations Army, so the PLA out of China. So we are, as a portfolio, dramatically underinvested compared to China, which is the second largest defense budget in the world, and there's a lot of talk around defense modernization and how we innovate on defense procurement. These are very common conversations in the DoD, but my concern is we're just not moving fast enough on it.
Well, I guess, Alex, in some sense, even for a company, an organism like Scale, the thing that was the biggest differentiator was data. Data is what's allowed you to become an amazing company and differentiate from everything that's out there and find all the new things.
It's a great learning of humanity that better data results in better AI. So, yeah.
Or real I.
Or real I.
Awesome, Alex. Really appreciate the time.
Yeah, thanks for checking out our new digs.
Yeah, super exciting. Can't wait for how this is going to turn out over the next couple of years.
It's such a trigger for me. Like, she's so nice, but it makes me so uncomfortable. I mean, you did grow up in a chaotic household, right? And all your relationships growing up felt pretty unsafe. You're so right. You know, I had to be the parent to my parents, and sometimes even my siblings. It was really chaotic. And you've also been hurt by a lot of people's intense emotions. Like, I remember almost all of those relationships. Oh my God, yeah, I have been through such horrible relationships. Honestly, a lot of the people that you
enterprises and anyone using these models, they need to know how to use their own data, their own know-how, their own expertise, their own trade secrets to combine with these powerful algorithms to actually build experiences that are, new, refreshing, different, and powerful to provide a lot of value to their customers. Military implementations of AI are going to be incredibly important. We need to ensure that in this next phase that the U.S. is both economically dominant,
on the show,
but also
Scale AI
has
founder and
military
CEO
leadership as
Alexander
well
Wang.
when it
His
comes
company
to
provides,
artificial intelligence.
accurately labeled data to help companies train their AI tools. And back in 2022, he became the youngest self-made billionaire in the world.
Hello. That was a long quote from you, Alex. My name is Garrett DeVink. I am a tech reporter at the Washington Post based in San Francisco, and I'm joined by Alex Wang, who you just saw that great intro about. It's really cool to see so many people here. Thank you so much for coming. This event was really oversubscribed, and I think we both go to a lot of events. We're both in San Francisco usually, and it's cool to come here to the other side of the country and see just the level of interest. And like in SF, it's kind of everything everyone's been talking about. Maybe we're even a little bit sick about it, but it's cool to say, okay, it's not just us. It's not just the weird, hippie commune out in the West Coast that's talking about this stuff. So thank you all for coming. Alex, I think we can just kind of jump right into it, but I just want to make sure for people who maybe haven't heard of Scale or maybe have heard of you but don't really know what you do, can you just in a couple sentences explain your company? Like, how are you different from a company like OpenAI or Google or Microsoft that's also doing AI right now?
Yeah, it's a great question. So I started the company back in 2016. I was studying artificial intelligence at MIT and this was the year when DeepMind came out with AlphaGo, when Google released TensorFlow, and it became very clear that artificial intelligence, even at that time, was going to be one of the most important technologies, certainly of my lifetime. And I started Scale really to build the foundations and power the development of AI with the most critical piece, the data. Since then, since starting the company in 2016, over the past 7 years, we've been a part of every major advancement in artificial intelligence. We've worked with many of the large autonomous vehicle efforts, including General Motors, Toyota, and many of the large automakers. We've worked closely with the US government and the DoD on many of the initial AI programs. I'm sure we'll talk about that here in a bit. And then we've worked very closely with the entire emergence of generative AI and large language models. We've worked with OpenAI since 2019, innovated on many novel methods and use of data for artificial intelligence, and work at this point with the vast majority of the AI ecosystem, players like Meta, Microsoft, and many others.
So it's kind of like picks and shovels of like this AI gold rush. Like you're selling the tools to help these companies develop these chatbots and LLMs and that kind of thing.
Yeah, I think our differentiated view is perhaps that this entire industry needs platforms and it needs infrastructure to enable to be successful. And so our view is the best way to enable that all to happen is to power it in infrastructure platform that everybody can use and the entire industry can benefit from.
I mean, you mentioned the government. Obviously, your quotes, your congressional testimony, talking a lot about military use, talking a lot about China, geopolitics. You have a $250 million deal with the Pentagon. I mean, that's a serious amount of money. Deal with military use, talking a lot about China, geopolitics. You have a $250 million deal with the Pentagon. A lot about your congressional testimony, talking a lot about military use, talking a lot about China, geopolitics. You have a $250 million deal with the Pentagon. I mean, that's a serious amount of money. I mean, why? Coming from San Francisco, it's not something that we hear a lot. We don't talk that much about even government tech and especially military tech. A lot of people out there are still uncomfortable with that. Why did you choose to kind of position your company this way to, really aggressively sell to the Pentagon? What's behind that choice?
Yeah, so I grew up in Los Alamos, New Mexico. For those of you who watched Oppenheimer, it was literally filmed in many places from my childhood. And both my parents worked for the National Lab in Los Alamos, working on fusion physics and weapons technology. And so I grew up in this hotbed of these incredibly brilliant scientists who had made it their career and made the decision to dedicate their lives towards building very advanced technology to ensure that we maintain US leadership. As artificial intelligence became a more and more real technology over the past decade, it became pretty clear that this technology was one of the very few technologies that had the ability to impact the balance of power globally. And in particular, the sort of, China published their strategy, Made in China 2025, of which chips and AI are some of the key tenets. They talk specifically about how they believe a future world will be primarily dominated by chips and semiconductors, and they need to invest heavily into that technology to enable future technologies such as AI. And so, in particular, I went to China. In 2018, I visited China. One of our investors organized this trip to understand the Chinese tech ecosystem. And in one of the companies, a Chinese facial recognition company, you walk in the lobby and there's a giant screen that shows like a video feed of the lobby, and your face immediately gets recognized as you walk in. And real time, you see your face be recognized. It recognizes who you are, your major demographics, like all this like very dystopian tech demo. And this was back in 2018, and basically realized that other countries were going to be particularly China, was going to be very, very dedicated in using artificial intelligence to power their country's ambitions, let's say. And this was, this is well reported. They use facial recognition technology very actively to suppress Uyghurs and for in building a global surveillance state. And it became pretty clear that, if you believe that AI is going to be one of these critical technologies, there had to be American companies who could help bridge the gap between Silicon Valley and DC, and could help bridge the gap between this incredible wellspring of technology and innovation that was happening in San Francisco, happening in Silicon Valley, and bring that technology to the US government to actually empower America to stay ahead, to stay in a leadership position.
Right. I mean, we just heard from Leader Schumer, and he was he said, we are ahead, or the US is ahead, but the gap is narrowing. That's sort of his characterization of it. You and I were just talking backstage about chips and kind of, how we're, a lot of time when we talk about AI, we think about software, we think about things that are, learning themselves. But at the end of the day, hardware is a huge part of this. And so, I mean, do you think that characterization of, ahead, but the gap is narrowing is accurate? And how do you think about this race, or this arms race, so to speak?
Do you like where you live right now? Could it be bigger, better located? Newer with better trans.
And then click confirm.
is 3, still.
Good code is good. We don't touch that. But for everything else, there's Sentry. Whether you're a mobile, back.
The only thing that happens here is that W is in fact determined. Did you notice down here 22/5 W equals 65/5 gives you right away W equals 3. Technically, that's W expressed in terms of Y times 0Y. So there we go. W is 3, still expressed in terms of Y. Z is 2, expressed in terms of Y. It's kind of silly, but nonetheless expressed in terms of Y. Y equals Y, also kind of silly. X expressed in terms of Y. There are infinitely many solutions here. The only thing that's sort of especially interesting about this case is that some of the letters are in fact fixed. W is 3, Z is 2. Some of the letters vary, but it can happen that one or more of the letters are fixed. The point, though, the global point for this section is that we have the leading variables x, z, and w expressed in terms of the free variables y. Okay. All right, so very good. So we can express here the infinitely many solutions using this criteria, and just as, for example, if you took y equals 1, you'd know that 2, 1, 2, 3 is a solution to this system. So that's sort of ideal, and that's a way to completely describe infinitely many solutions in a way that you can actually use it to determine what is and what is not a solution. So that's just about ideal. Okay, very good. So next time we're going to talk about a particularly convenient way to write write down these solution sets. That's called matrices and vectors. And so we'll see you next time when we talk about describing the solution set part 2. Whoops, there we go. It's describing the solution set part 2. Okay, very good. Bye-bye. Hi, hello.